Quick revision video on acids and bases. We'll start with acids. Acids are defined as proton or H+ donors. Acids can be strong or weak depending on the degree of dissociation or ionization in water. Some examples of strong acids are hydrochloric acid, nitric acid and sulfuric acid. And examples of weak acids are carboxylic acid, so we've got methanoic acid there, and ethanoic acid. Acids can be monobasic or monoprotic. That's where one acid molecule donates one proton, so HCl, HNO3 and CH3COH, ethanoic acid, examples of those. It's that proton, by the way, that's donated by ethanoic acid. They can also be dibasic or diprotic. That's where one acid molecule donates two protons. So you can see that with H2SO4, sulfuric acid. And tribasic or triprotic acids are when an acid molecule donates three protons. And the example there is H3PO4, phosphoric acid. So we'll take a closer look now at strong and weak acids. So strong acids are fully dissociated in solution, for example hydrochloric acid. So if you had a beaker with hydrochloric acid in, it would completely split up, dissociate into its ions. So in that beaker you would have aqueous H+ ions and aqueous Cl- ions. So we use the single-headed arrow to represent full dissociation. Weak acids now, they're partially dissociated in solution, so I'm using methanoic acid as the example. So if you put methanoic acid in a beaker of water, it would partially dissociate. So what you'd have in there would be methanoic acid molecules, aqueous methanoic acid molecules, methanoate ions and H+ ions. And the font size I've chosen here is to show that this is hardly dissociated, so you'd have a large amount of this molecule and small amounts of these ions. So we use reversible arrows to represent partial dissociation. Bases now. So a base is the chemical opposite to an acid, and so therefore bases are proton acceptors. Some examples of bases are metal oxides, metal hydroxides, ammonium hydroxide, metal carbonates and ammonia. Some bases are soluble in water and release hydroxide ions into the solution. So examples are metal hydroxides and ammonium hydroxide. Example there with calcium hydroxide. So if you took the solid calcium hydroxide, it would dissolve and you would end up with aqueous calcium 2+ ions and aqueous hydroxide ions. Bases can react with acids in neutralization reactions to produce a salt and water. And a salt is formed when the H+ ion of an acid is replaced by a metal ion or an ammonium ion. Moving on to neutralization reactions of acids. Acids react with metal oxides to produce salt and water. Example, hydrochloric acid with sodium oxide gives sodium chloride and water. Acid plus metal hydroxide also makes a salt and water. Sulfuric acid plus lithium hydroxide would make lithium sulfate and water. Acids also react with ammonium hydroxide to produce a salt and water. Nitric acid and ammonium hydroxide would make ammonium nitrate and water. And acid plus metal carbonate makes salt, water and carbon dioxide. And the example I've gone for is ethanoic acid and sodium carbonate makes sodium ethanoate, water and carbon dioxide. And finally, redox reactions of acids. So when acids react with metals, it's a redox reaction, not a neutralization reaction. And we get a salt and hydrogen. So the example I've chosen is magnesium with hydrochloric acid, making magnesium chloride and hydrogen. So that's a redox reaction because it involves a reduction and an oxidation process. The magnesium atom has been oxidized to magnesium 2 plus ions. It's done that by losing its 2 outer electrons. So the half equation to represent that looks like that. Those 2 electrons are gained by the hydrogen ions in the HCl, and they become hydrogen atoms and then combine to form an H2 molecule. So each hydrogen ion is reduced to a hydrogen atom, and they do that by gaining 1 electron each. And there's the half equation to represent that.